question which state that we should evaluate 2 whole number 1 over 4 plus 1 whole number 4 over 5, and the B part we are having another fraction 5 over 8 minus 3 over 8 dividing by 3 over 4. So we are starting with question A. So where we have 2 whole number 1 over 4 plus 1 whole number 4 over 5. Of course, the first thing I need to do here is to take LCM. LCM of 4 and 5 will give me 20. Of course, I will also add their whole number. This is the whole part of this fraction. Also, 1 here is the whole part to this fraction. If I add up the whole part, that's 2 plus 1. That will give me 3. Now, 4 goes into 20. I'm going to have 5. 5 multiplies the numerator, which is 4. I will still have 5. Then, 5 goes into 20. That should be 4. And 4 times 4 will give me 16. So at this point, if you look at what I have, I'm having 3 whole number. 15 plus 5 will give 21 over 20. So I have a fraction that is improper. 21 over 20 is an improper fraction. If 20 goes into 21, I'm going to have 1 whole number, remainder 1. The 1 whole number will be added to already existing whole number, which is 3. If I add that 1 whole number to 3 whole number, that will now give me 4 whole number. The remainder 1 comes up here over 20. And that's the answer to A part. So quickly, we go and do the B part, where the question is saying 5 over 8 minus 3 over 8 dividing by 3 over 4. Of course, we are to consider BODMAS here since we have more than one sign. And if we are to look at the BODMAS, I'm having subtraction sign, which is this one. I have division sign, which is this one. Their position in the statement BODMAS, division appeared first. This simply means we are to divide first. So to do that, I'll have to write this person down. If I want to work on division, I'm going to bring in multiplication. And if I do that, this 3 over 4, I'm going to take the inverse. That will now give me 4 over 3. So here now, 3 can cancel 3. 4 cancel out itself 1. 4 goes into 8. I'm going to have 2. I'm now left with 5 over 8 minus 1 over 2. Of course, this is a fraction that involves subtraction. I'll have to take LCM. LCM of 8 and 2 is still 8. 8 goes into 8 is 1. 1 times 5 is 5. 2 goes into 8 is 4. And 4 times 1 is 4. So at this point, 5 minus 4 is 1 over 8. And that's the answer to the question, number 1. Welcome to the next question. Number 2, the first question said, express 65% as a fraction in its lowest term. So the solution to A part here, 65% is the same thing saying 65 over 100. So I will look for a common factor to both of them, a number that can divide both numerator and denominator. And I know that 5 will be able to do the job. So if I put 5, if I use 5 to divide 65, that will give me 13. 5 comes here, I'm going to have 13. 5 comes here, I'm going to have 20. So the answer to this question is 13 over 20. We move to the next one, the B part, where the question says, the operation, this is defined over R. The R here is the real numbers by X operation y equal x minus y raised to the power of 2. And I'm to find the value of this 2 operation 3. This simply means that 2 have taken the position of x. The same happens to y. In place of y, I'm going to put 3. So if I'm to work on this now, where I'm having x, I'll put 2. And where I'm having y, I'm going to put 3 raised to the power of 2. Of course, 2 minus 3 will give us minus 1. If I'm to square minus 1, that means minus 1 times minus 1. And the result is 1. And that's the answer to the B part of this question. Okay, welcome to question number 3. Here we are to express this 0.0245 in scientific notation. Scientific notation simply means presenting it in standard form. So here, which after we are expected, they say we should correct this to 2 significant figures. So if I have 0.0245 and I'm expected to correct it to 2 significant figures, of course, I think I need to do this one. I will have to correct it to 2 significant figures before presenting this in scientific notation. So if I must do this to 2 significant figures, I will have to start from the first number that is not 0, and I will move 2 times. That will be 1 and 2. So approximately, I'm having 0.02. In place of, since the next number after 4 is up to 5, I'm going to add 1 here. So this will become 5. The next is to convert this number to standard form. So I'm going to have, if I move 1, 2. So I'm having now 2.5 times 10. Of course, you know that the format for a standard form is a times 10 raised to the power of n. And since I move 2 times, the value of my power will be minus 2. So that's the answer. Okay, welcome once again. For question number 4, the A part said we should find the exact value of 16 minus, in bracket, 3 plus 7 minus 2 plus 6 times 3. So here, let me write them out. Because we have different signs, both maths have a role to play. So I need to state it down. We call it board maths. In board maths, the first thing here is bracket. And in the inside bracket, I'm having 3 and 7. 3 plus 7. So I'm going to work with the person on bracket first. 3 plus 7 will give us 10. So this is the first person I'm to treat since it appeared first. Now, after that, I will open the bracket using the negative sign. That will be 16 minus 10 for the sign in the bracket is plus. So minus times plus is 3 minus 2 plus 6 times 3. So again, I'm having addition, I'm having subtraction, but I'm also having multiplication, which appeared before them. This is addition, this is subtraction, but multiplication appearing before them. So I'm going to multiply. If I say 6 times 3, that will give me 24. Plus, I'll bring the other ones down. So now, the next is addition. I'm going to add. See addition here. So if I say minus 2 plus 24, that will give me minus 22. Sorry, plus 22. I'll have 16 minus 10. So 16 minus 10 here will be 6, followed by 22. So if I should do that, 22 plus 6 will give me 28. So that's the answer to the first part. So going by the, if I want to solve the second part here, which is the B. Of because the first one is the A. They say I should express 0.06 as a common fraction. 0.06. So if I want to do that, see where the decimal is. Consider it anywhere the decimal is, put 1 there. Every other value will take 0. Now this is the same as saying 6 over 100. 2 comes here, I'm going to have 3. 2 comes here, I'm going to have 50. And if you look at it now, there is no other number that can reduce this job. So 3 over 50 will be the answer to question B. Question number 5. PQRST is a regular pentagon. QR and TS are produced to meet at U. Hence, calculate angle RUS. So we are looking for the angle where? Here. Angle RUS. But then we also have to consider this P Q R S T is a regular polygon or a regular pentagon. The regular here simply means that all sides are equal and all angles are equal when it comes to the pentagon. So we need to know each interior angle of this pentagon before we can calculate this person. So in a pentagon or in every polygon, sum of angles is given as n minus 2 bracket 180. Of course, this will now be, since it has 5 sides, I'm going to have 5 minus 2 bracket 180. This will be 3 times 180, which will give me 540. So now, I will need to know the value of each angle in this pentagon. So each interior angle will be 540 divided by 5, which will give me 108. That means every interior angle is 108. Each interior angle is 108. Now that I've gotten this, I will need to know here, and we know that this is angle on a straight line. The same thing here. If I'm able to get the angle here, then I can easily get this one. So let's assume here is x. I will now say the angle here will be 108 plus x equal 180. So x will now be 180 minus 108. If I subtract, minus 108 will give me 72. So that means the value here is 72. And you know that I should also have the same value here. 72, 72. And if you look at this, it's a triangle. Triangle RUS. This shows that it's an isosceles triangle. So for me to get the angle here, I will now say 180 minus 72 plus 72. If I add 72 plus 72, that will give me 144. And if I subtract, I'm going to have 36 degrees. 180 minus 144 will give me 36 degrees. This, therefore, angle RUS equal 36 degrees. I'm able to do this one, subtract them from 180, simply because I'm working on some of angles in a triangle. Question number 6. Given that P equal minus 2, Q Q equal 8 and R equal 12. Evaluate for A, R minus Q, B, Q square minus PR, and C, cube root of Q. So I'm going to start with A, where I'm having R minus Q. Of course, the value of R here is 12. In place of R, I'm going to put 12. For Q, which is 8, so if I subtract, I'm going to have 4. For 12 minus 8, we give 4. Then that is for A. The B part says Q square minus PR. Q is 8. So I'm going to put 8 and I will have to square the value since Q is having a square. Followed by P. And the value of P is minus 2. If you look here, there is no sign between P and Q. This means multiplication. And R is just 12. So 8 square will give me 64. I still have minus here. Minus 2 times 12 will give me minus 24. Now, minus will give me plus. For minus times minus will be plus. So I'm going to have this. 4 plus 4 will give 8. And 6 plus 2 will also give 8. So the answer to B part is 88. Then for the C, where I'm having cube root of Q, and the value of Q is 8. So that means we are talking of cube root of 8. Cube root of 8 here simply means a particular number you multiply 3 times to give you 8. If you check that, that should be 2. Another way you can do this, you can still rewrite 8 as 2 raised to the power of 3, as 2 times 2 times 2 will give me 8. So in index form, it's going to be 2 raised to the power of 3. Of course, cube cancel cube root. The value of this is 2. And that's the answers to question 6. Question number 7. It is given that V varies inversely as the square of T. Some corresponding values of V and T are given in the table below. So we are to find the value of A and B. We have to find the values. We have to find the values K, A, and B. So we have to follow the first statement that says V varies inversely as the square of T. This means V varies inversely as square of T. So of course, this variation sign will be replaced using V equal K times 1 over T square, which means V equal K over T square. And this is the relationship holding them, at which they varies. Of course, having K over T square means that I have multiplied K with 1. So now, I need to know the constant value of constant, which is K, before I can get the value of A and B. So the corresponding value of V here is 25. And the value of T is 2. But which have to be squared since T is squared. This means 25 K over 4. 4 times 25 should be 100. So now that I've seen the value of the constant, I can now get the value of A and B. So if I want to get the value of A, I must go back to the relation. So I will write V equal, instead of writing K, now I'm going to write 100 over T square. So who is in place of V? That is A. In place of T, that is 5. That is 5 square. So that means that 100 over 25 the result will be 4. With this same relation, I'm going to get the value of b. I will still state down the relation v equal k over t square, where v is 1 over 4. v is 1 over 4, k is 100. T square, the person in place of t now is b, so it's going to be b square. If I clear fraction, I'm going to have b square equal 4 times 100. Of course, I may decide to take square root from here. If I take their square root, the square root of 4 is 2, and that of 100 is 10. So that means the value of b is 20. I've seen that k is 100, and the value of a from our calculation is 4, and that of b is 20. Number 8 question. Solve the simultaneous equation 2x equal 5y and x minus 2y equal 3. So I will have to state it of this equation 1, this one, x minus 2y equal 3 as my equation 2. So it's obvious that it's not a case of elimination. So I'm going to make use of substitution method. I will start with equation 2, where I want to make x the subject. So here I'm going to have x. I'm starting from equation 2. From equation 2, where I'm having 2y minus x minus 2y equal 3. If I want to make x the subject, minus 2y we have to cross. That will now be 3 plus 2y. Now that I've made x the subject in equation 2, I'm going to substitute the value into equation 1. Substitute x into equation 1 since I started from equation 2. And equation 1, I'm having 2x equal 5y. In place of x, I'm going to put 3 plus 2y. Instead of writing x now, include the value of x. Now, equal 5y. 2 times this, 6. 2 times this, 4y equal 5y. Of course, I'm to collect like term. 4y and 5y are like terms. That will be 5y minus 4y. And if I do that, y equals 6. Now that I've gotten the value of y, I can now move ahead to get the value of x. So I want to substitute y into equation 1, where I'm having again 2x equal 5y. Of course, it must not be equation 1. You can make use of equation 2. So at y, I will put the value of y, which is 6. This is 2x. 5 times 6 is 30. If I divide both sides by 2, the value of x will be 15. So we have seen that x is 15, while y is 6, and that's the answer to the question.